Hello guys, welcome to Rotational Dynamics, kinetic energy of rolling body and acceleration of it in an inclined plane. So now for kinetic energy of a rolling body, here this rolls with angular velocity omega and moves with velocity v, let's say it has mass m. In this case, it has the kinetic energy of both translational motion and rotational motion. So that means the total kinetic energy is the sum of both. This is 1 by 2 mv square plus 1 by 2 I omega square. Now let's write the rotational terms in terms of translational motion. And so here, moment of inertia, let's say this is mass into radius of gyration square k, and omega, well, v equals to omega r, so omega equals to v by r, which is v square by r square. Here from both we can take 1 by 2 mv square common. So 1 by 2 mv square. Here is 1 plus k square by r square. This is it for kinetic energy of rolling body. Now for the acceleration part. For the acceleration part, typically the derivation is not asked, but it will be helpful in certain numericals that may be asked. But if you have to derive it, you will know how to. So let's start with a figure. Now let's say this is height h and inclined initial angle is theta. Let's denote it by A, B, C. And let's say the rolling body here has mass m with velocity v and rotational angular velocity omega. And let's say that AC, the distance AC equals to s, right? This whole part AC is equals to s. Now here for a body, if we start it at the top point, then it has high potential energy, and as it rolls downward, the potential energy gets converted into kinetic energy. So what this means is that the potential energy loss is equals to the kinetic energy gain during any instant when it's rolling down. So here this is mgh equals to 1 by 2 mv square, but since this is kinetic energy of a rolling body and we have just derived it, it is 1 plus k square by r square. Now here mass cancels and the 2 goes here. So let's just write it in terms of v square because it will be easy to get acceleration from velocity. So v square will be equals to 2gh and this whole thing will come downwards, giving us 1 plus k square by r square. Now here we have height, but we want distance s because the rolling body is rolling down AC. So here sine theta is equals to h by s. So that means h equals to s sine theta. So let's put that in here. You're getting v square equals to 2gs sine theta by 1 plus k square by r square. Now let's solve for v square. Do you remember any equation of motion having v square and possibly acceleration as well? There is one. We have v square equals to u square plus twice as, right? So here the initial velocity, if we have the ball right here, the initial velocity is 0, and here v square equals to twice as. So let's just put it in this equation. So here this becomes twice as equals to 2gs sine theta by 1 plus k square by r square. Now here the 2 cancels and the s cancels. Therefore we have acceleration equals to g sine theta 1 plus k square by r square. This is required, and this is the end of rotational dynamics, and in the future video we'll be doing another topic which I'll reveal in a later video. Thank you.